so the first one, a 4 kilogram object is traveling south at a velocity of 2.8 meters per second. When it collides with a 6 kilogram object traveling east, so just like your cars. If these two objects stick together upon collision, at what velocity does the combined masses move? So just as our other collision questions, you have to write out your before and after. So my one object's traveling south. It has a mass of 4 kilograms. And since it's going south, you need to set that V equal to negative, right? Negative. Then you can solve for P. And then I have another object traveling east. Its mass is 6 kilograms. Its velocity is positive 3 meters per second. So my P is 18 kilograms times meters per second. Okay, so now let's think about our P and our Px and Py. So this vector just represents Py, right? There's no x coordinate here, so this is Py. So Py total is just negative 11.2 kilograms times meters per second, because that's the only y that's here, because there's no y vector here. And same, this is just all Px. So our Px total is equal to 18 kilograms times meters per second. So that's all of our before information. So then, to figure out our after information, we make the assumption that the sum of our Px is equal to the sum of our Px prime, and the sum of our Py is equal to the sum of Py prime. So that's the assumption that we use throughout the rest of the question. So now let's write down what happened after. So I'm going to use that assumption and make a new triangle to represent what happened after. So I had momentum that was going east, and I had momentum that was going south. Okay? That was my total momentum east and my total momentum south. So this P of x is 18 kilograms per meter second, and this P of y is negative 11.2 kilograms times meter per second. But the question asks, at what velocity does the combined mass move after the collision? So that needs to be our P net. Well, we need our P net to find our velocity. So our P net is equal to question mark. Well, and we know our mass. Well, I'll just go with this first. So to figure out our P net, we use a squared plus b squared equals c squared. So it's 21.2 kilograms times meter per second is our P net. Did I put something wrong? Oh, yeah. Because when you're squaring it. Okay, so now since the object's stuck together, we need our total mass. Okay, so for this, we need MT. So we have our 4 kilograms plus 6 kilograms is our 10 kilograms. Our question's asking us about velocity, so V equals P net over MT. So our velocity is 2.12 meters per second. But this is actually only our speed right now, because we need to add direction in order to make it our velocity. So what we do is we look at our triangle, and you go to the tail of the net, and that's the angle you need to find. So to find that angle, we can use our tan function. You could use actually any function if you want to use your hypotenuse already too, but I'll just use tan since it was information we had first. So our theta is equal to inverse of tan of 11.2 divided by 18. So theta is 31.89. So that's the value of theta, but what's its direction? I'm just going to scroll up for a second. We have north, east, south, west. It's on the east line, and it went south of it. So it's south of east.
About 34 degrees.
I don't know.
No.
No, that shouldn't. Yep, make sure you're in degree mode too in case. But you shouldn't have gotten something that close. I still got 31.8. Oh, did you go 11.2 divided by 18?
Oh, I did
Yeah, maybe you just wrote it down. Yeah. Okay, then our final answer, let's put it all together and put it into sig digs. So how many sig digs in this question? 2. Okay, so we have our V with our arrow, you know, if we're going to be really specific, because that indicates velocity, not speed. And it's 2.1 meters per second, comma, 32 degrees south of east.
So in calculus, instead of using, is it D?
Pardon me?
Instead of using D, they used S. Or
Instead of B, they use S.